phosphorus. Gives a resulting flux of about 950 pounds per year of nitrogen from wastewater and about 2,500 pounds per year of phosphorus. However, for reasons that we discussed earlier, that concentrations went up, and so now our nitrogen flux to the nearshore waters is very large, about 19,000 pounds per year. And one neat thing about working in the Department of Health is a lot of data comes across your desk that apparently has no relation to whatever you were doing before. This actually came as part of a UIC permit, Underground Injection Control Permit. The resort in this area wanted to go to RO to generate drinking water, reverse osmosis. Well, you've got to get rid of the wastewater. They wanted to inject it. So they did a test boring, which happened to be right in the middle of our wastewater plant. As part of that test boring, they did a salinity and salinity in blue here, and a temperature profile. Well, we already identified temperature as an indicator of the wastewater flow. Also, we know that the salinity of the wastewater plume was reasonably low compared to seawater. So we wanted to see, well, is there a possibility, because we only monitor the nearshore waters, is there a possibility that some of that wastewater gets trapped underneath whatever retarding confining layer and gets discharged deeper and further offshore? If that were to occur, we should see an anomaly, particularly in the temperature data, relative to the salinity data. Actually, should see kinks in both data sets, and none occur. So this seems to validate some modeling that had been done, again with Maui injection of wastewater back in 1977. Burnham had modeled and stated that, yes, you're going to inject the wastewater deeper into the saline zone, but it's buoyant and it's immediately going to migrate back up into the freshwater zone and be discharged closer to the shoreline, not as we desire to be discharged deeper and further offshore. Now, the Lahaina cap rock is thin, so this may not be applicable elsewhere, but that salinity, temperature profile does strongly indicate that vast majority of the wastewater gets caught up into the freshwater zone and discharged near shore. Well, this kind of become a rather exciting part. This was litigation. And Craig just shook his head. Yeah, real exciting. Well, he didn't find it as exciting as I did. In 2011, actually, as we were gearing up to do our tracer test, the Hawaii Wildlife Fund and a group of environmental groups filed suit against Maui County alleging violation of the Clean Water Act. Okay, they're in negotiations, litigation. This goes on for about 4 years, well, 3.5 years, something like that. And so in January of 2015, federal judge Susan Maui decides the case in favor of the plaintiffs, i.e. Maui County is in violation of the Clean Water Act. So what are the applicable issues from our perspective? First off, there are two laws that govern, that come into play here, the Safe Drinking Water Act and the Clean Water Act. What are the legal points? And from our perspective, what role did the Lahaina Groundwater Tracer Study play? So Clean Water Act. And it regulates discharges into what's called the waters of the United States. Generally, that refers to surface waters. It requires a permit, the National Pollutant Discharge Elimination System permit, or discharge permit. It has very strict limits on the nutrient content in that discharge, about 0.15 milligrams per liter. And this is at the pipe, not at the point it's entering the environment. Safe Drinking Water Act. It regulates sources of drinking water, including injection into potentially drinking water aquifers. And it requires what's called an underground injection control permit. And the contaminants there are regulated by the drinking water contaminant rule. So in there, the allowable nitrate, which is basically equivalent to total nitrogen in oxygenated water, is 10 milligrams per liter. So there is a big difference between that number there and that number there. This one, at the pipe, would be very difficult for Maui County to reach. This one, they reach now without any difficulty. So Maui County originally operated under a UIC permit. That UIC permit expired in 2009. Currently operating under administrative extensions while all this is being sorted out. But what was kind of exciting about this was we have two potentially conflicting federal laws. This had the potential to go to the Supreme Court, which I thought was kind of neat. Craig did stir my enthusiasm. So the judge's decision, okay, what role did the study play? Actually, it turned out a pretty big role. Judge's decision was based upon a proven connection between the injection wells and the nearshore waters, and also the estimated fraction of wastewater discharging into the nearshore waters. It was estimated to be significant, greater than 50%. And in the opinion of the judge, the above constitutes a discharge, a point of discharge into the waters of the United States, i.e. nearshore recreational waters. And also based on the judge's decision, this ban stated that Maui County may have been in violation of the Clean Water Act since the UIC permit expired in 2009. If it is viewed legally that way, could result in enormous fines. The damages, however, were to be determined here last month. But as reported in the Maui News, the two parties are close to negotiating a settlement. And this is kind of a side note, don't know if it had anything to do with it, but in June of 2015, EPA issued a revision of the Clean Water Rule, basically how they're going to apply the Clean Water Act. And the paragraph is kind of long, but the optimal point here is the rule also does not regulate shallow subsurface connections nor any type of groundwater. Whether that motivated the settlement or not, I don't know, but it did seem to say that we should be regulating wastewater injection under the UIC, therefore the Safe Drinking Water Act. Now, of course, another major way we deal with wastewater that will affect groundwater is on-site sewage disposal. An example here is a house. Wastewater goes to septic tank, settles, all the solids settle out. The liquid is dispersed to a leach field, which then is subjected to treatment by soil, and eventually some of that will wind up down in the groundwater. That would be great if the majority of our OSDS were septic systems. We have about 110 OSDS in the state of Hawaii, and they could discharge as much as 70 million gallons per day of wastewater into the environment. The majority of these OSDS are cesspools, about 88,000, which would represent a potential 50 million gallon per day discharge of wastewater with no treatment into the environment. The Big Island has by far the greatest number of OSDS and cesspools. And that's kind of even between the other three major islands, Kauai, Maui, and Oahu, although keeping in mind that the Big Island is called the Big Island because it's the biggest. So you have a fairly high concentration of OSDS on Kauai. Molokai, not so much. Okay, with that wastewater discharge comes pollutant and primarily nutrient discharge. About 12,500 kilograms per day of nitrogen and about 3,600 kilograms per day of phosphorus. And that's 70 million gallons per day of wastewater that's discharged. So again, what goes into the groundwater does not stay into the groundwater. It gets caught in the groundwater flow and is captured either by wells or by discharging to streams or coastal waters. So, University of Hawaii, we did a study on on-site sewage disposal systems. As part of that, to actually look at the impact that OSDS discharge may have on the groundwater, modeled the addition of nitrogen to the groundwater resulting from on-site sewage disposal systems. So East Hawaii, in an area of particular interest to be Hawaiian Paradise Park, if you look at that development and upgrading of that, there are about 10,000 cesspools in the groundwater flow path to the ocean. Another way to look at it, in the inset here, we have the OSDS density. In the red areas, you're approaching up to 1,000 OSDS per square mile. Now, paper that was written for the EPA back, I believe, in the 80s stated 40 OSDS per square mile could have a significant impact on groundwater. So that is potentially a big impact. But the clustering or the density of OSDS is not the only thing that has to be taken into account. East Hawaii is also an area, a very wet area of high groundwater recharge. You have a lot of groundwater coming out gradient. It is going to dilute that leached wastewater. And so the modeled groundwater nitrogen concentration was just barely above background, now less than a milligram per liter above background, in this area of incredible density of cesspools. I'll contrast this with the smaller development to the south. This is an area with much less groundwater flow, less recharge, and so it actually, the modeled groundwater nitrogen got bumped up to the next level, the 1 to 5 milligrams per liter. Now this is modeling. Modeling has uncertainties, but looking at data that DOH collected here at Hawaiian Paradise Park, and that is collected as part of the permit condition for operating the geothermal plant, see very low groundwater nitrogen here, and about 1 to 2 milligrams per liter of nitrogen here near Leilani Estates. But nitrogen was not a problem. Also in Hawaiian Paradise Park, it does not served by the county water system, so people are putting in drinking water wells. So we have about 250 drinking water wells in this community of about 4,500 residents. So on each parcel you have, at those 250 parcels, you have your drinking water well, your domestic well, and you have your OSDS, which is likely a cesspool. Probably not a good combination. So we did just some basic drinking water screening for bacteria in the water samples collected at 32 different wells. And half those wells tested positive for total coliform, which is an indicator of wastewater, but there are other sources of total coliform. More definitive of wastewater would be E. coli, and about 25% of the samples tested positive for E. coli. So you're down here, notice that as you approach the coast that the incidence of detection increased also after a heavy storm. Well, that makes sense. These bacteria leave the human body. They don't like it out there. They tend to die off. The closer you get to the coast, shorter distance between the ground surface or the bottom of the cesspool and the groundwater. So does that mean that all these people up here in the green area are safe? Well, probably not, because we're looking at relatively short-lived bacteria. So the most problematic pathogens are longer-lived viruses. And so the question would come, well, why don't you sample for viruses? Well, they're expensive to analyze for, but also, most of the time, we're not sick. So even if you expend the money to analyze for viruses, you're going to come up almost all the time with non-detects. But we can take the lessons learned here and extrapolate it up here. Now, on the good news part, most of the well drillers have put in wells here, so there's a package, where that package is a filter, a micron filter, and also a UV disinfection system. We strongly encourage the use of the disinfection when we met with the community while we were doing this study. Now contrast this to West Hawaii. East Hawaii, we had an area of very high recharge, very high amount of groundwater dilution of the OSDS effluent. West Hawaii, area of much lower recharge, still significant number of OSDS. So instead of 1 to 2 milligrams per liter, we got up into exceeding 10 milligrams per liter. This is simulated, not measured, simulated groundwater nitrogen from OSDS leachate. But one of the questions is, okay, this is a model, can we validate it? Well, some of our colleagues from the botany department had previously did a coastal nitrogen 15 survey, put out algae specimens, let them equilibrate with the marine chemistry, pick them up, ran them up, analyze them, and look for the nitrogen 15 and nitrogen 14 ratio. Elevated nitrogen 15 indicates wastewater, lower concentrations show ambient. So I plotted along here, and this correlates to the map here, the simulated groundwater nitrogen in blue here, and the measured nitrogen 15. Look for correlation. Just visually, didn't do statistical analysis, but just visually got a pretty good correlation. Now, one thing that Dan Amato has shown is that you can increase the agreement there, the correlation, if you take into account wastewater injection, which occurs along the west coast of Hawaii. But the key point here is that we do have a measurable signal that does seem to validate the qualitative groundwater modeling. Also currently being done by the Geology and Geophysics Department by Christina is looking at 3 sets of submarine springs. We've got Black Point here. Black Point is below the grade of the roadway, which is where our sewer mains commonly run. So this area was never sewered. Compare that with Guadalupe Peninsula and Pauakui Beach Park, areas that are sewered, very few, if any, OSDS. Look at 3 primary wastewater indicators, the delta N15, the total nitrogen, total phosphorus. These bar graphs are graphed relative to the Guadalupe Peninsula, which is the control site. So we look at, okay, Guadalupe corresponds very closely with Pauakui Beach Park, not much different. But in all cases, for all 3 indicators, that water collected off of Black Point has elevated delta N15, elevated nitrogen, and elevated phosphorus. So we do have a measurable impact in the water discharging at measurable wastewater impact in the water discharging to the marine environment. Okay. If people recall about a year ago, this was in the news, there was a complaint received at the Department of Health about people recreating the Kahalu Lagoon and coming up with nasty infections. And so I think some of the members of this audience actually went out there and did some sampling and got really high bacteria counts because that sampled on a stormy day. And here was the sample points, and as all cases, red is bad, yellow is warning, green is good. Well, all of the bad and warning occur down here, downgrading of all this large number of cesspools. And this could be occurring by 2 different processes. One could be overflow during storms, direct discharge into streams, and also that leachate going into the groundwater and discharge into streams and directly into the marine environment. But not only do we have a measurable impact, but we have an adverse health impact from on-site sewage disposal systems. So what's being done? Well, a couple of major things are being done here at the Department of Health, down there at the Department of Health. First off, revising the wastewater regulations. This is being done to not allow any new cesspools. It was actually attempted last year, and because of the way the regulations were written, there was a lot of blowback. Not the ban of new cesspools, but we wanted to go beyond that and start replacing existing cesspools. The other is, so okay, now we're going to encourage upgrading existing cesspools in critical areas. So this last legislative session, Act 120 was passed. And what that says is in certain designated areas, the state will allow a $10,000 tax credit for a cesspool to upgrade to septic or to be connected to a sewer. These tax credits are available for 5 years, starting in 2016, will extend to 2020. But there is a $5 million cap each year. So you run those numbers, that comes out to be about $25 million over 5 years. Best estimates is that there are about 6,900 qualifying cesspools. However, the payout cap limits the benefits to 2,500. Now, we don't know whether we are actually going to wind up even providing tax credit for all 2,500 because the cost of an upgrade is greater than $10,000, usually in the $25,000 to $30,000 range. So it still is a significant financial burden, but the payout to the environment would probably be a good investment. So what are these qualifying areas? First would be within a 2-year time of travel to a drinking water well. This is part of the source water assessment program, which the University of Hawaii did the groundwater modeling for. The other would be remove those cesspools that are right adjacent to critical water bodies that receive water from groundwater. This would include wetlands, perennial streams, and also the shoreline. So where does this leave us? Well, it leaves us with wastewater as a fact of life, with a lot of conflicts. We all generate it, we don't want to deal with it, but all the options for dealing with it have potential for adverse consequences. Wherever we put it, somebody's going to be unhappy. It's going to result in lawsuits, new laws, or new regulations. So it's kind of a team effort. We as managers and regulators, I'm talking about the Department of Health, we need to work to minimize or eliminate the adverse impacts. The academic community also plays a role here. Need to keep current with the issues. Once current with the issues, design and propose scientific studies to address the issues. And as was seen in Lahaina, the environmental community also plays a part. They keep the rest of us honest. So it is a team effort. And that brings me to the end of the presentation. I think Ryu's kind of fell off the edge here. We have time for a couple of questions. Yes.
That was a wonderful, wonderful discussion. I enjoyed it a lot. One comment though, on West Hawaii, you mentioned about how hot the cesspool issue is there. There's lots of anecdotal information around there about people drilling cesspools and hoping that they hit a lava tube. And in fact, the director of Annie Lake told me a wonderful story about someone downslope who was drilling a cesspool behind their house, and the drill string dropped into the lava. And they said, great, we got a lava tube, we're done. They pulled the drill string out and they had an artesian flow, little geyser of sewage in their backyard.
That comes under poetic justice?
Yes.
I'm guessing that there's probably not much handle of that in the groundwater models.
No. Well, one thing, in the groundwater model, actually, it would simulate that more closely. because in the groundwater model, we assumed no attenuation once it left the zone of treatment. So with cesspools, it was a maximum of about 60 milligrams per liter assumed in the leachate. If on a septic system, then that would be, I can't remember what the number was, but 5 milligrams per liter. In the example you gave, yeah, the model would be accurate, but let's move up to Mountain View. Mountain View, or even Central Oahu, thick soil cover, so you would get a lot of incidental treatment. But yes, in West Hawaii, the cesspool is not a good idea. Hawaiian Paradise Park, same thing. Absolutely no soil. There was a study done, I think back in the early 90s, where somebody put a data logger in a well in Hawaiian Paradise Park, let it log, and then looked at the rain, and I think it was within a few hours of the onset of heavy rain, you've seen an increase in the water table elevation. So there you have the vertical travel time in the hours at the most, where in Central Oahu, months and maybe years travel time.
Question up front here, Bob.
Pardon? Oh, yes.
I just want to make 2 points.
Okay.
The first one is a scientific one, that you are able to determine the specificity value as 25 meters.
Yeah.
But that's extremely important piece of data.
Yeah.
And congratulations.
Thank you. Yes, and that's the neat thing about the tracer test. You can actually directly measure dispersivity rather than estimate it. Although it was actually estimated by modeling.
Only and I was trying very hard to put a figure on what the hydraulic conductivity of the very fresh upper flow on the west coast of Hawaii, remember that.
Yeah.
And so it's a very valuable bit of information, scientific information. Thus, I will talk about past. That could help to mention that the injection well, I had the privilege to participate in perhaps the first injection well test in 1953 in California. And we were using what you described brought back my memory because I was a full graduate student doing all the sampling at night. The tracer we used was actually iodide 131. I don't know whether it's any common, iodide 131. So, but and that besides the porosity and rotary and all that, so on. But I have some over time how to manage the wastewater into the underground, the compatible, the wastewater meeting groundwater. What I seem to have not heard today is a land treatment system, and that's applied to the wastewater on a living filter vegetation, and let the vegetation do the cleaning up of the nutrients, and then permit the leachate or percolate into the underlying brackish water or groundwater. And along that line, one of my last projects before I retired 20-some years ago was done at Everplain. You're familiar with that? You're
not
familiar.
intimately familiar, but I do.
You're familiar with that?
Yeah.
Okay. And it just seems to me that project consider to be a very practical alternative of handling wastewater. And still, sort of, so to speak, to make it compatible with underlying groundwater. And so I hope the health department would pay some attention to the land choices.
Yeah, actually, since I do work with the health department, I need to go back, because I remember you, I think we did the tracer was rhodamine dye, right? Yeah, and I don't remember the specifics, but I do remember the tracer.
I think the audience is Roy Hardy. Roy, are you still there?
Yeah, back here.
From the Water Commission.
Yeah.
Roy was a hard-working graduate student working on that project.
Yeah, and if I recall from our conversations, you also found some interesting things about groundwater flow direction too, that were not expected. Well, thank you, Sue. Oh, Lindy.
Yeah. Bob, I want to congratulate you. I thought that was an excellent presentation.
Thank you.
And you did a great job of showing how data and research from the university informs the regulatory process for Department of Health. But one thing that strikes me is that Department of Health may or may not act on that information. You know, for example, they haven't issued an NPDES permit for Lahaina, despite the findings of the tracer study and the judge's ruling. And then, and they haven't banned cesspools.
Well, we actually, we wound up with a lot of opposition, even with the, okay, and last year what the proposal was to require that at the point of sale that any property with a cesspool would have to upgrade to a septic system. And there was a huge amount of blowback from the realtor community, and they prevailed. And I think that's part of some of the reason why we don't always, Department of Health does not always act. Well, that's not all the reasons.
They have a whole other set of factors that they consider in addition to the scientific information. One question that I had though was about the proposal to fund cesspool replacement within, was it 200 feet of the critical resource? And do you believe that's sufficient? 200 feet is enough of a buffer?
And actually, we've had discussions about that. And that actually was, although we did help with the wording of that law was generated by one of the representatives. Actually, I think it was a senator and it was a co-sponsor. But there are ongoing discussions. Again, part of the OSDS study, and I keep bringing this up to my colleagues, is that was to identify those high-risk areas and actually assign scores. And so I think as we move beyond Act 120, need to concentrate on the high-risk areas, because if you're out in rural Hanaku or something, where there's one cesspool, but it's within 200 feet of the shoreline, well, you know, who really cares? But if you're in an area like Wailua or something, where you have a big cluster of cesspools that, you know, extend inland, you know, half a mile, you're probably going to get a lot more. It's going to be expensive, but you're going to get a lot more bang for your buck by doing something about that large density of cesspools. But that's something we still have to work through. At least we got to start. I think they first tried to ban cesspools in the early 90s, and it actually turned out that this sewage study played a role in informing everybody, hey, we do have a problem with on-site sewage cesspools.
Thanks for the great presentation. I work for the Surfrider Foundation. We're trying to do a lot to inform people about the cesspool upgrades in what they can do with it.
Mhm.
Do you have any comments on composting toilets and whether that is a viable upgrade within that bill, and are they a viable solution for the future?
Well, I see some person with a hand up to ask me a question, but he could probably answer that better.
Well, no, I'm not gonna answer that.
Oh, okay, because I don't know about that. I would, think possibly, but I'm not the wastewater engineer, so I really can't address that. Yeah.
Yeah, I did want to comment on the difference between, with respect to Act 120 and the difference in cesspool, septic tank, and urban treatment unit. It seems to me that depending on the situation, the difference between a cesspool and a septic tank is really not the septic tank itself. It's the dispersal field, the leach field, whatever you want to call it. That's the only place you're getting any treatment that would change any characteristics of what's getting leaching in the groundwater. So you got potential for some nitrogen and phosphorus removal there, but that's fairly limited. And in these places where you have high concentrations, they're close by, and they have soil that's not very good for dispersal field to actually produce anything, either need or nitrogen or phosphorus. And so there may be no improvement, especially when you have a high density, and like in Hawaii and on Big Island, where you have very poor soils, and so you have essentially just injection. The septic tank's not going to help you there at all. Instead, you should look at reservoir zone, Caesar, and then it requires nitrogen removal and a treatment plant at the house. So you should then instead, that actually would make more sense for the upgrades rather than converting cesspool into septic tanks. Septic tank in those high-risk areas is not going to make much difference. You need a treatment unit. And those technologies exist, and they don't necessarily cost more because you don't then need the dispersal field. You can keep your cesspool as an injection, but you're now injecting clean water that's been really treated to secondary or tertiary levels, including disinfection. That's what we did. We looked at in some of our models.
Well, that's kind of one thing that I do bring up periodically is that the septic system discharged to a seepage pit is not, and then the report actually does show that there's not much improvement. But one question that occurred to me is elevated beds, are they also an option for a leach field?
I'm not sure what's allowed at that.
And I don't know what the relative costs of each of them are, but yeah.
So we've kind of gone over time here. There's a couple more questions. Go ahead.
Do you have any judgment about how the change in concentrations might vary if you took the Lahaina wastewater and instead of injecting it in the ground and treated it in R1 distributed to irrigation system to plantation ag field to the mouth of that earth?
Well, there you get actually what Roger was referring to. You get soil treatment. So,
If you can find the users.
yeah.
No, but I mean, would that mitigate the problem on the concentrations in the ocean to a large extent?
I'm sure it would. Well, one thing, you would get dispersal. There wouldn't be a point discharge. And the other, you would get the advantage of soil treatment, incidental, but it is real and will occur.
Can I just add to that, the golf course that you use there with the water, you see one motion runoff in groundwater.
Surface runoff.
Groundwater. So,
Okay, one more over here, and then we'll have the conflict.
Great. A quick plug for these type of treatment systems, whether it's composting or constructed wetlands. I want to say one chart I didn't see, or one bar graph I didn't see on your chart was the polluted, the sewage spills and leaks. I think this year we've seen over maybe neighborhood of 10 million totally accumulated. And so these large-scale municipal delivery systems are aging and failing, and that's another thing to consider, I suppose, when we're looking at the staining of groundwater in the nearshore environment.
Definitely important. I guess the thing that we were concentrating here would be the chronic discharge of pollutants versus and managing that, the acute events also potentially for it.
Of course you can. What? Please, go ahead.
I want to congratulate this method semantics. I'm glad to see the word groundwater and wastewater, both of them one word. Groundwater is one word, wastewater is one word. And over my time, we struggled for the longest time to make them one word, and this prevailed.
Actually, in the journal Groundwater, there was, I think, an editorial that said just that.
Okay, so let's wrap up our talk. It was entitled Groundwater Meets Wastewater. All right, so thanks very much.